Hello, welcome to the LMS, sponsored by Department of Collegiate and Technical Education. Now I am presenting session two, session two of module three of hydrology and irrigation engineering with code 17 CV 73 for 7th semester civil engineering students. In this session two, before going to the session two, in the session one, we have discussed about some definitions, then about the runoff and some of the formulas used to compute the runoff, like uh, empirical method. Then we have discussed about the hydrographs also. Now we are going to discuss in detail what exactly is hydrographs, the definitions, components of the hydrograph, and the base flow separations. So in the session two, these are the contents we are going to discuss. Let's again go back to the hydrograph. See, in the common terms, hydrograph is a graph presenting the relationship between the discharge and the time. However, in a broad sense, the graph showing the stage, velocity, or other properties of water flow with respect to time is also called as hydrograph. It's not only run, the runoff versus the time, it also gives some more information about the runoff. A hydrograph is plotted between the flow stage and the time. It's also called as stage hydrograph. The stage hydrograph is used in the form of stream gauge record. With the help of hydrograph, the runoff can be computed in the following ways. The first one is runoff volume. The runoff volume formed by a given rainfall event occurred in the watershed is determined by calculating the area of hydrograph resulting from the said rainfall event. In contrast, in case of a perennial stream hydrograph, it is determined by deducting the contribution of base flow from the hydrograph and computing the area of new hydrograph called direct runoff hydrograph. We can also compute runoff rate. At any time instant, the rate of runoff can be directly read from the hydrograph. In addition, the time of peak runoff occurrence and what is the extent of peak runoff can also be directly read from the hydrograph. So these are some of the things which are used from the hydrographs. And duration of runoff. A hydrograph also provides the information about the total time of runoff flow at the outlet of watershed due to a given rainfall event. Let us understand what exactly is hydrograph. Hydrograph is in the form of a continuous loop of smooth curve which starts at origin point of runoff formation and rises up with the increase in runoff with the advancement of time and attains peak which continues till the rainfall ends. Thereafter starts decline and terminates to the point where runoff stops. So it is in the form of a continuous loop of smooth curve. It starts at the origin point of the runoff formation and rises up with the increase in runoff. With the advancement of time, it attains peak which continues till the rainfall ends. Thereafter, it falls down or declines and terminates to the point where runoff. I'm going to show you a hydrograph, a typical hydrograph. See here, a graph has been plotted between flow versus time. Flow is in the y-axis, time duration, rainfall in the x-axis. So it started from this one. You have a minimum flow here, Then the graph is going up, rising up. That is called rising limb, and it has attained a peak. What we call it as top of the peak or the crest of the peak, and it's falling down as the time passes, which is called as falling limb. Then recession joins the, and it has been divided in two colors. The dark one or the dark blue is called the base flow, and the top one is the quick flow. So this is the graph, a hydrograph, a graph plotted between flow and the time. So basic definitions about these graph, the hydrograph features you can also call as rising limb. I'll go back again to this one. Rising limb is where the curve is starting going in the upward direction. Rising limb, what is this? It is the curve or the line joining the starting point A, starting point A of the rising curve and the point of reflection. The shape of the rising line is influenced by the rainfall characteristics. So that is how it is. The as the time goes, the flow is also moving up. Second one is called the peak, or it's also called as crest. What is this crest? Let's see. It represents the highest point position of the hydrograph. In the hydrograph, it is the highest position, and its duration also depends on the intensity and duration of rainfall. Its duration also depends on the intensity and duration of the rainfall. So again, we'll go back to this. What is the crest? Rising limb going up, and then the crest. And another point, this thing, the feature we have to keep it in mind is the falling limb, also called as depletion curve. It is the descending portion of the hydrograph. No, the hydrograph, the shape of the falling limb, it mainly a function of the physical features of the channel alone and is independent of the storm characteristics. And that means it depends on the basin characteristics. It doesn't depend on the rainfall characteristics. Falling limb. Again, I'll show here. Crest is going down and the falling limb and the recession curve. Time to peak, TP. What is this? It is the time to peak from the starting point of the hydrograph. Starting point of the hydrograph, you see the time duration, and that is called the TP. And another definition you have to keep it in mind is lag time. What is this? This is the time interval from the center of the mass of the rainfall to the center of the mass of the hydrograph. It's called the lag time, or it is the total duration or time elapsed between the starting and the ending of the hydrograph. So we have discussed the definitions of rising limb, peak or the crest, depletion curve, time to the peak, and the lag time. And another thing you have to understand in the hydrograph chapter, the session is the base flow separation. So let's go back to the lesson. Here I have shown in the graph. Under this graph, there is a blue color, dark blue, which is called as base flow, and the quick flow. What is this base flow separation and why it is needed and what is the use of this? Let's understand. In an hydrograph analysis, the separation of base flow is required to determine the contribution of direct runoff out of the total runoff. You have to keep it in mind. It is required to determine the contribution of direct runoff out of the total runoff against a given rainfall event occurred in a watershed. It's presented by the hydrograph of perennial and stream rivers. So I'll again tell you, it is in hydrograph analysis, the separation of base flow is required to determine the contribution of direct runoff out of the total runoff against a given rainfall event occurred in the watershed presented by the hydrograph of perennial streams or rivers. In other words, for deriving the unit hydrograph from the annual runoff hydrograph, the separation of base flow is done. So we are going to discuss the unit hydrographs in the next session. So in other words, for deriving the unit hydrograph from the annual runoff hydrograph, the separation of base flow is done. The annual runoff hydrograph annual runoff hydrograph includes the base flow and the direct runoff both. The base flow is the off-season water flow through the stream or river, which is mainly due to the contribution of the groundwater. The groundwater contribution to a river or a stream makes it to carry the water flow throughout the year. Such stream or rivers are also called perennial stream or river, and the generated hydrograph is stretched for the year period. So how the base flow is done, base flow separation is done. There are number of methods. The important methods are the method 1, which is called as straight line method. Let's see what they do, how do they do the base separation. In the straight line method, the beginning point of surface or direct runoff and the point representing the end of the direct runoff on residual limb are joined together by just a straight line. The area below the straight line represents the contribution of base flow from the total runoff. In figure, the point A is the beginning of the direct runoff and point B is the direct runoff. I'll show it is in the next slide. See here, point A is the beginning of the runoff, point B is the end of the hydrograph. So the area below the straight line represents the contribution of base flow from the total runoff. In figure, the point A is the beginning of the direct runoff and B is the end of direct runoff. The beginning of the direct runoff is usually identified in view of a sharp change in the runoff rate at the point or time concerned. In contrast, the exact location of the endpoint is difficult. However, the following empirical formula can be used to determine this point A, which is n is equal to 0.83 into a to the power of zero point 0.2, where n is the days from the peak towards the recession limb of hydrograph, a is the drainage area in kilometers. This is the simplest of all methods. See here, just they have point A is found out, point B can be found out by the graph. Otherwise, you can use an empirical formula, join the line, and anything below this line is the base flow. This is how they do the base flow separation in the straight line method. There is another method, or it's also called as method 2. Let's see what do they do, how do they do the base separation. In this method, the base flow separation is carried out by extending the base flow curve existing prior to the commencement of the surface runoff to intersect the ordinate drawn at the peak. Intersected point C is joined to the point B by a straight line. B is the endpoint located at end days from the peak. The area below the segment AC and CB demarcates the base flow and above to the surface runoff. This is the most widely used base flow separation methods. Now I will show how it is done. Here the point A is located, then the peak value is taken, the point C is located, line is drawn to the point A, it is continued, then from the B that point is joined. Anything between AC and CB is the base flow separation, and this is most widely used base flow separation method. And base flow separation is needed to find out what is the amount of base flow. So these are the references that are used. Thank you.